everybody, in this video we're going to be talking about polarity and water solubility. Okay, so from our learning we should know that if a molecule is polar, it will most likely be dissolved in water, or most likely water will dissolve it. So what we're going to do is we're going to test that theory by mixing certain compounds with water and seeing what the results are. In these test tubes, I have nothing right now. They're just empty test tubes. You can see there's nothing in them. But what I'm going to do is I'm going to fill them about halfway, just above the level of the test tube rack cross member here, so you can see them, and we will see if compounds will dissolve in water. So I just have plain old tap water, and I'm going to do that right here. So now we have water in all these test tubes. So what I'm going to do is I'm going to leave this particular test tube just with water in it. That way you can kind of see what it looks like. You can see the interface. Okay. And then I'm going to get a blank piece of paper so that you can see if the compound dissolved or not. Okay, so let's get started. You'll see what I mean by a blank piece of paper. I'm going to use it as a background. Okay, so we're just going to go in order of the compounds on the sheet, so that you can then write down whether they dissolve in water or appear to dissolve in water, and then whether you think that they're polar based on that result. Okay, so we're first going to start with sodium chloride. This is a solid, okay, and so we will put sodium chloride, we'll take a little bit and dump it right into the test tube, and we will stir it around. One of the ways that we like to stir a test tube is we hold it very snugly on the top, and then we hit it with two fingers like this. Okay. So I let the salt sit for some time, sodium chloride, and you can see that this is the empty test tube, the one without any water in it. And so you can see that there's nothing dissolved in it, or nothing different about this. And now here is the one with, here's the one with the salt in it, and I look up and you can see that there is no difference between these two things. So it appears that the salt has dissolved. Okay, so now we're going to get a liquid. We're going to go with a liquid, and so here is hexanes. Okay, hexanes, this is an organic compound. So what I'm going to do is I'm going to take the hexanes and I'm going to add it right to this test tube. Okay. I want to get enough so that everybody can see if something crazy happens. Now we take this out and we mix it up. We hold it very firmly at the top. Then we take two fingers and we smack it on the bottom. Okay, and you can see without even the white piece of paper here that this has two layers that has formed. Okay. You can see very clearly there the two layers that have formed, and even if I go up, look, you can see the two layers. So the question is, does hexane dissolve in water? Yes or no? Okay. Okay. So now we'll do the same thing. We'll do it with mineral oil. Okay. We'll add mineral oil to the test tube. Again, you can see the same sort of thing going on there. So I'll take it out, I'll shake it up. I will hold it very, very firmly at the top, and I will use 2 fingers to mix it up. Okay, I'll even swirl it around, and I think you can see compared to our just our water sample, again without the white paper, you can even see the 2 layers there. Let me get out the white paper just to make sure that you can see it. Okay, you can see that there is 2 layers, especially when I do that. See the interface at the very top of your screen there? You can see the 2 layers. Okay, so when I get close, then you can really see it. Okay, so that was mineral oil. The next liquid we have is isopropyl alcohol. That's rubbing alcohol. It's just kind of the normal alcohol that you would find in a medicine cabinet to clean out a wound. So I'm going to grab a test tube. So you can see it kind of mixing at the top. Okay. And again, what I will do is let me add it so that you can see what happens. I'll add it like this. Okay. You can see the top gets a little bit cloudy. You can see the top gets a little bit cloudy here, but once it's allowed to mix up here, okay, again, we're looking at the top. If I bring this up, notice it's the same consistency all the way through. Okay, same consistency all the way top and bottom. There's no boundary between 2 different layers. So that's isopropyl alcohol. The next compound we're going to do is cornstarch. Okay, some of you may have mixed cornstarch and water in the past, but I'm not going to mix it enough to make oobleck out of it. I'm just going to put a scoop in there to see what happens. So I'm going to take a little bit, okay, put it in there, and if we look, we can see that now the solid didn't dissolve. Okay, the solid didn't dissolve. You can see it on the bottom. You can see it on the bottom right there. Okay, so I'll grab the top of it tightly, and then I will hit it on the bottom. And again, you can see on the bottom, see the solid forming on the bottom. Not forming, but the solid kind of falling down to the bottom. So this is cornstarch. So when we compare that to salt, which was the first one, sodium chloride, you can see that sodium chloride, there's none down at the bottom, and it's all 1 layer. Let's try, okay, 4 more of these. So I've turned this around to get a new set of 4 empty test tubes with just water in them, and then our sample that just has water in it. Okay, and we'll take baby oil. Okay, just off-the-shelf baby oil. Okay, and if we're going to add this, so again, grab the top of the test tube very firmly, and we mix it up. Okay, but you can see, even in this poorly made video here, you can see as I bring this up, you can see there, right there is the difference between the 2 layers. You can see 2 layers forming right there. So now we have, it's hard to see, but this is because the label's all screwed up. That says glycerin. Okay, glycerin. Okay, so I'm going to take glycerin and I'm going to pour it right into the thing here. Okay, you can see it fall right down to the bottom here. Yuck. Okay, you can see it right there. You can see the glycerin has fallen down to the bottom, but what happens when I stir it up? So again, I'm going to grab it tightly at the top, and I'm going to smack it with my fingers. Okay. So if we look at glycerin, okay, we can see on the bottom that layer isn't there anymore. Okay. So again, if I use this and we look, okay, you can see all one layer, all one layer, all one layer. Even at the bottom, it's formed all one layer. So that definitely dissolves. Okay. So now the last couple. This one is calcium carbonate. Okay, calcium carbonate. I'm going to take a scoop. This is a solid, so I'm going to take a scoop of the calcium carbonate and put it right in the test tube. And much like the cornstarch, you can see on the bottom that this didn't dissolve. Okay, you also can tell because it's white. Okay, if it dissolved, it would have looked like the salt water would have looked like. This is completely dissolved. It's all colorless. Okay, this didn't dissolve. You can see it on the bottom. Okay, but it didn't dissolve also because it turned white. You can see that the water turned white. Okay, so I'm stirring it up. Okay, you can see that it's still not dissolving. Okay, so last but not least is kerosene. Okay, I brought a little kerosene in from home and I put it in this bottle. So what I'm going to do is just add kerosene to this test tube. I'm going to add kerosene to this test tube. So let's see what we get. Okay, so in the video it's a little hard to see, but whew, smelly. But if we look here, again, I'll grab it, I'll mix it up. Okay. Okay. So now if we look, we can see two different layers. 1, 2. Okay. You can see it interface as I move it along that way. You can see the white layer interface. Okay, so this exemplifies how some compounds are soluble and some compounds are not soluble in water. Okay, so have a great day.